Hi, this is Sharmila Nagesh. I'm a postgraduate teacher in chemistry, and my qualifications are MSc Chemistry and B.Ed. I have around 10 years of experience teaching children from various grades across various syllabus and also from different parts of the world as well. So today, here I'm there to give you a small demo on the topic of chemical properties of alcohols and phenol. So this actually falls under one of the chapter in grade 12 Victorian curriculum. So let's jump into the topic. So we all know that alcohols and phenols, they are the type of hydrocarbons. So before moving into this topic, let's have a quick introduction about the hydrocarbons. So hydrocarbons are generally, they are the components with hydrogen and carbon in them. So they are the making material of many kinds of objects and materials which are present in this world. So if an component contains hydrogen and carbon in them, so then they are called as the hydrocarbons. And also and the other name of hydrocarbon is what we call as the organic compounds. So generally, organic compounds, they act as a parent material, and many other components can be actually derived from that hydrocarbons. So alcohols and phenols are one type of hydrocarbons which are present in this world. So apart from alcohol and phenol, also there are different types of hydrocarbons like esters, carboxylic acid, ethers, ketones, and there are so many of them. So today we are just, discussing only a small topic from that huge topic actually. So jumping into the topic, reaction of alcohols with metals. So alcohols again, it's one of the type of hydrocarbons, and when alcohols are treated with metals, they form alkoxide and hydrogen gas will be liberated. So when I say metals, so elements actually can be classified into three types: metals, non-metals, and metalloids. So metals are one type of elements which are present in the periodic table, and also there are different kinds of metals, and we can always classify the metals based on the reactivity. And there is a series called reactivity series. So where the elements present at the topmost part of the reactivity series, they are usually very reactive. So sodium, potassium, or they are the first metals which are present in the reactivity series. So here, when alcohols are treated with an active metal, so active metal in the sense they are very much reactive. They can actually react with any kind of components and at a very faster rate and give so many kinds of products at a very faster speed. So alcohols, when they are treated with active metals like sodium and potassium, they form alkoxide and hydrogen gas will be liberated. So hydrogen gas, hydrogen always it exists in the form of a gas. So when they are actually formed as a byproduct, they get to liberate at the end of the reaction. So this is how it goes, and there is a general reaction to explain this reaction actually. So when 2 moles of alcohol, so here this is a general formula to represent the alcohol, ROH. So in the place of R, we can substitute any kind of alkyl group like methane, ethane, propane, butane. Any kind of alkyl groups can be substituted in the place of R. So based on the type of alkyl groups which are substituted in the place of R, the name of the alcohol actually differs from one compound to another. So when 2 moles of alcohol are treated with 2 moles of sodium, what happens is the hydrogen from the alcohol, it gets separated and it tends to liberate in the form of a gas. So hydrogen is one of the byproduct which are formed at the end of the reaction. So apart from that, so in the place of hydrogen, after the hydrogen gets eliminated from the alkyl group, that is from the alcohol, sodium, it occupies the place of the hydrogen in the alcohol group and it forms sodium alkoxide. So 2 moles of alcohol, when it is treated with 2 moles of sodium, they tend to form sodium alkoxide and hydrogen gas will be liberated. So this is how the alcohols actually reacts with metal. So alcohols can also react with other kind of active metals like potassium and aluminium as well. So this is how alcohols generally react. And then, so here is actually an experiment where we can practically see that hydrogen gas is liberated. So we can always take a beaker or is a conical flask. Since the opening of the conical flask is, it's very narrow. People usually prefer this conical flask for this experiment. So what we're going to do is we are going to take a small amount of ethanol in the conical flask, and we're going to add a few pieces of sodium metal to the ethanol. So ethanol is an alcoholic group, and it's a type of alcohol because it has got ethyl group in them. So when ethanol it reacts with, like when it comes in contact with the sodium pieces which is dropped into it, it starts to liberate hydrogen gas. So already I've told you that sodium is a very reactive metal, because it's at the topmost of the reactive series. So it has got an immense tendency to react with another compound. So when sodium is dropped into ethanol, it reacts with ethanol and it starts to liberate gas, that is the hydrogen gas. So when I attach a balloon at the mouth of the conical flask, the hydrogen gas which is being liberated from the mixture, it tends to fill up the balloon and the balloon starts to rise. So from this experiment, we can actually understand that when sodium pieces are reacting with ethanol, they liberate hydrogen gas. So this is one kind of experiment, where we can actually understand hmm, the reaction of the alcohols with the active metals. Okay, so there are few other examples, to understand this property. So the experiment which we have done is, given in the form of equation here. 2 moles of C2H5OH plus 2Na gives 2 moles of C2H5ONa plus H2. Here, C2H5OH is nothing but it's ethanol. So ethanol in the sense that ethyl group is being attached to the OH group, that is the alcohol. OH is nothing but it's the functional group of alcohol. So when ethyl group is attached with the OH, it forms ethyl alcohol. So when 2 moles of ethyl alcohol are treated with 2 moles of sodium, sodium tends to replace the hydrogen from the ethyl alcohol and it forms sodium ethoxide plus hydrogen. So in the product formed, you can actually see that it has got two types of ions in them. So one has got the negative sign and the other has got a positive sign, which means that one is a cation and the other is an anion. So there are two different types of charged particles present in the product form. And since both of them are actually charged particles, the type of bond between them is actually an ionic bond. So ionic bond is generally formed in compounds, in which there are two different charged particles. If a compound has got positively charged and negatively charged particles, so this ionic bond will actually connect both of them, because an ionic bond will only form when there are two charged ions, when one cation and when one anion is present in a compound. They can obviously form a charged compound by means of the ionic bond. Okay, so this reaction was practically discussed in the previous slide. Then there's also another example where when an organic compound is treated with 2 moles of aluminium, so aluminium tends to replace the hydrogen there and it gives you a different kind of product. So this is how the reaction of the organic compounds, that is the alcohols with the active metals, actually takes place. Next one. So far we have discussed about the reaction of alcohols with the active metals. Now we are going to see how does phenol react with metals. So phenol is actually a very interesting compound actually, and it has also got many kind of applications in day-to-day real life actually. So phenol, as I said, so it is also a kind of organic compound. So when phenol are treated with metals, that is with active metals like sodium, potassium and aluminium, they form phenoxide and liberate hydrogen as a byproducts. So when we were discussing about the reaction of alcohols with metals, we have seen that the product formed are alkoxide and hydrogen. But then in this case of reaction of phenols with metal, it actually forms phenoxide and hydrogen gas will be liberated as a product. Now we'll see how the reaction proceeds. So here the reactants in this reaction are 2 moles of phenol when they are treated with 2 moles of sodium. Sodium, since it's a very active one, and also since the sodium is very much reactive, than the hydrogen, it tends to pull the hydrogen out of the phenol, and it occupies the place of the hydrogen in the phenol. So it leads to the formation of sodium phenoxide, and hydrogen will be liberated. That is, the hydrogen which has been removed from the phenol will be obtained as a byproduct. So this is how the reaction proceeds. So here you can see that the hydrogen from the phenol is actually removed, and sodium has been replaced in that place of hydrogen, and the removed hydrogen has been obtained as a byproduct. Since sodium ethoxide is present, the sodium compound is attached to the phenol, so the product formed is sodium phenoxide. So this is how the reaction proceeds. Next one is esterification. So esterification is also a very important chemical reaction. So esterification is actually a very interesting one. So esterification is nothing but it's a type of reaction by which the esters can be actually produced. So esterification can be produced by carboxylic acid, acid anhydride, and also by acid chloride. So when one out of these three compounds are treated with alcohol, they can actually lead to the formation of ester along with water as a byproduct. So people has to keep in mind that whenever esterification is taking place, ester will be formed. Along with that, water will also be formed as a byproduct. So this is how a esterification reaction proceeds. The formation of ester always takes place along with the formation of water. So this is how the esterification proceeds and the products are formed. So now, alcohol, when they are treated with carboxylic acid, so the functional group of carboxylic acid is nothing but C double bond O OH. So this is what we call as the functional group of carboxylic acid. So the components in the different shade represents the functional group, and the same way for alcohol, it is nothing but OH. So OH is the functional group of alcohol, and C double bond O single bond OH is nothing but it's the functional group of carboxylic acid. Now when both of them are reacted together, or when both of them are mixed together, what happens is hydrogen will be removed from the alcoholic structure, and the rest of the component tends to attach themselves with that of the alcohol. So one hydrogen from alcohol and OH group from carboxylic acid, they connect together or they join together and they get removed as water. So this is how the water is formed as a byproduct. So the rest of the compounds will attach together and forms the ester. Since ester is formed as a product, this kind of reaction is what we call as the esterification. So once again, I'll repeat, alcohols, when they are treated with carboxylic acid, the hydrogen from alcohol and the hydroxide group, that is the OH group from carboxylic acid, both of them will join together, or both of them will connect together and they get removed as water. So the thing is that hydrogen has got a positive charge and OH minus ions have got a negative charge. So that's the reason both of them are attached together and they're forming a new product. And we have to understand that this kind of reaction always takes place only in the presence of an acid or in the presence of a proton. So without the presence of a proton, the reaction is not going to proceed. So since this reaction is taking place in the presence of dry hydrochloric gas as a catalyst, this reaction is known as the Fischer-Spear esterification. So this is a very important concept, and also this is one of the most repeated questions in the examination. So this reaction takes place only in the presence of a dry hydrochloric acid as a catalyst. So when I say catalyst, catalyst is nothing but, it's a component which increases the speed of the reaction. So whenever a reaction is taking place, if a compound increases the speed of the reaction, then that kind of component is what we call as a catalyst. So there are also components called retardants. They will they'll try to decrease the speed of the reaction, but in this case of esterification, dry hydrochloric acid is actually increasing the speed of the reaction. So that's why we call them as a catalyst. Yeah. So far we have discussed about the chemical properties of alcohols and phenols. So we have got a chance to actually discuss about the reaction of alcohols with metals and also the reactions of phenols with metals. And also we have learned about the esterification as well. I hope this demo session was very much interesting and useful for you.